Okay, students, we're going to be tackling our Unit 2 review today. Let's take a look at our bell work first. All right, so here is our bell work. So it wants us to find each quotient. So again, this is a review from what we did yesterday. We are going to set this up. It says 6 3/10 divided by 3/10. So I'm going to just make sure I have the right color here. We'll use this one, so we can see what's going on. So we have 6 3/10 being divided by 3/10. Okay, so remember from yesterday, we move our decimal over one place here. So we move it one place here and put it up in the answer there. Now, we just treat this like a regular number. We can forget about that 0. So 3 goes into 6 twice. That gives me 6. I subtract, I get 0. I bring down my 3. 3 goes into 3 times. And that is our answer. You could put a 0 here if you wanted to. It wouldn't change the value, but there's no need. So we'll just leave it at 23. Okay, let's take a look at this one. This is saying 2 7/100. So I'm going to write that down. 2 7/100 being divided by 3. There is no decimal to move, so we're just going to bring our decimal straight up. Put it right there. Does 3 go into 2? No, so it's 0. Does 3 go into 20? Yes. So it goes 6 times, and that gives me 18. I subtract. I get 2. I bring down my 7. 3 goes into 27 9 times. So that is 69/100. So hopefully you're getting the hang of this. From what I looked at yesterday, the students in my class, we were doing really well with that. So makes me feel good that you're good with that. Emma says the greatest common factor of 16 and 12 is 48. Her friend Grace says the answer is 4. Explain who is right. So the best way to, when you're trying to decide if somebody's right or if somebody's wrong, is just to do it. So we're going to find the greatest common factor of 16 and 12. And I use the cake method for greatest common factor. So what number do they have in common? Well, you could say 2, but you can also say 4. I'm going to go 4. It goes into 16 4 times. It goes into 12 3 times. So our greatest common factor, well, we know that there's no factors that go into 4 and 3. There's our candles. Our greatest common factor is 4. There's our answer. Pretty simple. So it looks like Grace is correct, and Emma, too bad Emma, could have listened more in math. Number 3, we're writing less than or greater than to make each statement true. All right, well, 2 is less than 7. Look at this next one. Well, negative is less than 4. Negative 5 is less than 4. 0 is less than 3. So pretty simple. Moving along, we're going to go negative 3 is less than 0, and negative 1 is less than 1. So pretty simple there. You can use the number line to kind of compare numbers, and what it means by that, let's look at that for a minute. I want to look at the negative 1. So a negative 5 is right here, and 4 is over here. So which one's bigger? Well, the one that's always to the right is going to be bigger than the one that's on the left. So that is why the alligator eats the bigger one. So that's kind of how you use the number line to do those problems. Okay, let's move on. There is no practice for today. It is just the review. And so the way that I'm going to go through this review, I don't want to do every problem for you. I'm going to do one on each of the sections, and then I am going to maybe give you some hints on the other ones and have you solve those for yourself. So let's take a look at this first page here. I'm going to make this second page a little smaller so it's out of the way. So I'm going to take a look at this one. So I am going to do number 1. So number 1 says 3 times 8/9. So I am going to go 3 over 1, because remember, a whole number over 1, it doesn't change the value, times 8/9. Now, if you remember, we always check for cross products. The 1 and the 8 are already, if there's a 1, you can't simplify it any further than that. It's just the way it is. But the 3 and the 9, what numbers go into 3 and 9? Well, 3. The 3 changes into a 1, and the 9 changes into a 3. Now we're going to multiply 1 times 8 is 8, and 1 times 3 is 3. Now that is an improper fraction, so we have to change it into a mixed number. That's saying 8 divided by 3. So I'm going to go 8 divided by 3. 3 goes into 8 twice. That's 6. We take our 2, bring it up here. Our 3 goes right here. So 2 and 2/3 is our answer. All right, I would like you to try number 2 on your own. So make sure that you do that one on your own. Also, number 3, it's saying find the area. I'm going to set this one up for you, but I'm not going to solve it. It's 2 1/4 times 3 1/2. So hopefully that helps you out. Again, remember, you do need to change these into improper fractions before you try to do your multiplication. All right, let's move on to number 5. Number 5 is dividing fractions. So there's one thing that's different from dividing fractions than multiplication. It's the keep it, change it, flip it. So I'm just going to write that there to help me to remember to do that. So I'm going to keep this fraction. So I did that. I kept it. Changed the symbol to multiply. Okay, I did that. And I'm going to flip or reciprocate. It's a reciprocal. So I'm going to reciprocate the second fraction. So 6/5. Again, now it's just like multiplication. So I check for cross products. Do 7 and 5 have any common factors? No. Do 6 and 9? Yes. They have a common factor, so we can do simplifying. So 6 and 9. And 3 goes into both of those. 3 goes into 6 twice. So my 6 turned into a 2. 3 goes into 9 3 times. My 9 became a 3. Now we multiply. 7 times 2 is 14. 3 times 5 is 15. 14/15 is my answer. Is it an improper fraction? No. So it's done. We're good. If it was an improper fraction, we would have to change it. All right. So number 6, the setup for that one, I'm going to help you out a little bit, is 8 2/3 divided by 2/3. So there's the setup. Remember to change the mixed number into an improper fraction. Keep it. Change the division to multiply, and then reciprocate or flip the 2/3 and turn it into 3/2. Okay. So now it wants us to write the reciprocals on this one. I am going to do, number 9. So number 9, I have to change it into an improper fraction. So let's make that bigger. So 10 times 1 is 10, plus 3 is 13. My denominator is 10. Now I flip it. 10/13. There we go. That's how you do it. So just remember, if you have to do something to that, this might help you on this one. Put it over 1, but you have to flip it. Reciprocate means flip. All right, so that should help you out on that first page. Let's shrink that guy. Where did my other page go? Okay, I found the other page. It was hiding. So here we go. Let's do a couple of these. So add or subtract. Which one do you want me to do? I'm going to do the subtraction. So I rewrite these so I can solve them. I've noticed a few students are trying to do these in their head. It's not a smart move, guys. You need to really write these down and write them and do the subtraction or the addition. Remember, with addition and subtraction, we have to line up the decimals. And that is the key to doing that. And then we would put a 0 in any gaps that we have. Now I can subtract. 1 minus 0 is 1. 3 minus 7. I can't do that. I have to borrow. So that becomes a 10. Oh, I'm sorry. It becomes a 0, and this becomes a 13. 13 minus 7 is 6. I have 0 minus 5. I can't do it. I have to borrow. So I borrow from the 4. It becomes a 10. 10 minus 5 is 5. I see my decimal, drop it down. 4 minus 1 is 3. 1 minus 1, well, 1 minus 1 is 0. So you can put the 0 there, or you can leave it off. Up to you. 3 567 thousandths is how you say that. Okay, so you need to do the addition one. Now we're multiplying with decimals. I am going to do number 4. So I'm going to just write this down. Doesn't matter which way. You can put either one of these numbers first. In fact, I want to put the 4 and 42 hundredths on top. So I'm going to do that. And then you don't have to line up the decimals here. But this one happens to have them line up. It's not a big deal. So we're going to multiply. 7 times 2 is 14. 4 times 7 is 28 plus 1 is 29. 4 times 7 is 28 plus 2 is 30. Put a 0 on the next line. 2 times 2 is 4. 2 times 4 is 8. And 2 times 4 is 8. Put 2 zeros on the next line, and then everything else is 0, because 0 times 2 is 0. 0 times 4 is 0, and 0 times 4 is 0. Now I'm going to add 4. 9 plus 4 is 13. 8, 9. 8, 9, 10, 11. And 1. I moved the decimal over twice. 3, 4 times. There's 4 times I moved the decimal, so I have to move the decimal 4 times here. So I'm going to go 1, 2, 3, 4. And it goes right there. So it's 1 and 1,934 10,000ths is how you say that answer. Okay, number 5. The rainfall in Annette, Alaska in September is 31 hundredths inch per day. How much rain falls over the course of September? And September has 30 days. So the setup for this one, guys, is 31 hundredths times 30. So that's what you're going to do on that one. Okay, let's move on to the division. I am going to do number 7 because it looks like fun to me. So we're going to go 12 hundredths divided by 3 6/10. Again, I'm moving the decimal 1 place here. So I have to move it 1 place here and then move it up into my answer. So I'm just going to put it right there, nice and big. Now I just treat it like a regular old division problem. So I'm going to go 36 does not go into 0. 36 does not go into 1. 36 doesn't even go into 12. Oh my gosh, what am I going to do? Oh yeah, we have to put a 0 on there. Okay, does 36 go into 120? Well, let's see. 36, I'm going to estimate a little bit here. Let's try 5 times and just see what happens. 3, 0, 15, 16, 17, 18. Whoa, that's way too big. That's 180. So we better go smaller. 36 times 3, 189, 108. That looks about right to me. So we're going to go 3 times. That's 108. Woo! I subtract. I get 12. I bring down another 0, and guess what? It's the same thing again. It's 120, just like it was up here. So I know it's going to be another 3. But you know what? It's just it's going to repeat over and over. So the answer would be 33 thousandths, and it's just going to repeat over and over. So that's why I wanted to help you out with that one. That one's a little bit weird. So, okay, look at number 8. Number 8 says your mom gives you $12 to spend at the school store. You decide to buy 1 Laffy Taffy each day for 50 cents. So how many days can you buy a Laffy Taffy? So we're going to actually I'll help you set this one up. It's $12 divided by 50 cents. Okay, so solve that one. Number 9 and number 10. It wants you to find the greatest common factor of 18 and 27 and then find the lowest common multiple of 18 and 27. That's kind of a review from last chapter. I think you can handle that one. I want to see what you come up with. Guys, good luck on this. Do your best work. Try your hardest, and I know you'll succeed. If you do have questions, feel free to ask your teacher. We're here to help you. Good luck.